So last time we were doing stuff, we were on page 60, we had talked about the tripod, we talked about the earth not being, well, the earth is round, but the earth being round is not why our tables and stuff rock. And we would have been gearing in on 11. So 11 and 12, you're supposed to draw some drawings. So on your drawings, what have I been trying to coach you to always just draw what part of the drawing first?
Shapes, like the front and back.
The front. So we'll do the front first. The front is all solid lines, so that's probably better. Then after you draw the front, why do I encourage you to draw the back next?
It's just like a mirror.
It's just a mirror. It's a match of the same shape. Just be careful, because some of the back is going to be what kind of drawing?
Dotted.
Dotted. And then connect the corners. So 11 and 12, that would be my continuing advice. 13 is a no. It feels like a yes. It feels like the plane postulate. It's close to being the plane postulate, but they skipped a word. They're talking about 3 points, and it feels like a yes, but what word did they skip in the phrase 3 points that's a helpful word? Non-collinear. Since they didn't say 3 non-collinear points, it doesn't play out. Anytime they start talking about 3 points, why do you have to be careful? What are the scenarios?
Line or a triangle.
A line or a triangle. So since they don't specify on 13 what kind of thing you have, you're just out of luck on that. 14, people don't often understand 14, so here's the idea of 14 if you can make eye contact. This is a circle that's not in the plane of your eyes. This circle is in the plane of my board or wall. If I put this circle in the plane of Melissa's eyes, that's what I'm doing. It no longer looks like a circle. You no longer can see that looks like a circle. What does that look like to your eyes if this is put into your plane of your eyes? A line is warm, but not a line, but that's close. Why line segment, not line? It has a beginning and an end. A line would have to go forever in 2 directions. So right idea, best idea is line segment for 14. 15, they want to draw intersecting lines that are in a plane. How would you draw intersecting lines that are in a plane? What's that going to look like?
Draw a plane with an X or
An X. It's going to have an X. 2 lines in the plane of your paper are going to make an X. If you want to then drop in a 3rd line that touches them both, but is not in the same plane, how am I going to draw a 3rd line that touches them both, but isn't in that same plane of my board or your paper anymore? It's going to have to go through it, like this way. How would we draw something that's like an arrow piercing the board through it?
make like half of it a dotted line,
Half of it's a dotted line because it's going behind.
the other half solid.
The other half is solid because it's coming at you. Then it would have to touch that same point. That's what you're going with on 15. 16, I think, is where this one stops, right? The finish line of this homework. So 16, they draw you 3 lines. They ask how many planes they determine. Well, determining planes is what vocabulary question? What's the answer when I talk about determining planes on the quiz?
3 non-collinear points.
3,
2 intersecting
2
lines.
intersecting lines is what we're gearing in on this. So 16, 2 lines at a time would determine these planes. So what would be one pairing that makes a plane? Line number, who and who? It takes 2 lines to determine a plane. So let's find 2 lines that would determine a plane. Who with who on page 61? Okay, 1 and 3 make a plane. 1 and 2 make a plane. 2 and 3 make a plane. Any more? Or is that what we got? We're going to run out eventually. Is that all right? That's it. We got 3. There's 3 planes determined by that. Line 1 with line 2, line 1 with line 3, line 2 with line 3. There's 3 different planes that you could determine in that scenario, and that's page 60. Can I do anything more to help you with your life on page 60? Okay, 65, here we come. 65, the name of the game for the beginning part was convex. Basically, if something has a hole in it, it is not convex. If it's some sort of a solid thing that includes an inside, then it is convex. So, for 1, can somebody tell me on 1 somebody who's not convex? Looking for the no's on 1. Anybody have a no on number 1? Let's try this while we think too. What's different if I say a circle versus a circular region?
The circle is like the outer part of it.
Correct?
And then the circle region is like the whole circle.
Okay, includes the inside. So circular region, any kind of region includes the inside. Anything that it just says circle, it's just the outline of it. So, is a circle convex? No. Circular region?
Yes.
Yes. So most things where we say region are going to be yes. Most things without the word region are going to tend to be no's. But again, anybody on 1? Spot me a no.
C.
C is a no. 1 C is a no. I agree. There's 3 more no's afoot.
B.
B is a no. Agreed. And then in E, they ask 3 questions. 2 of them are no's.
The first 2.
First 2 are no's. I agree with that. So 1B is a no, 1C is a no, 1E starts off with no, no before they hit a yes. 2. I've got like 6 no's in the process of number 2. Somebody spot me other than Joseph on 2, spot me a no. Anybody on 2? Have a no anywhere? B is a no, that's true. A is a no, that's true. And then there's questions with multiple no's. D has 2 no's, E has 2 no's. It's just a question of which ones are the no's. Anybody on D have 2 no's out of 3? It's first and last. D is going to go no, yes, no. Anybody on E have a thought on the 2 no's? I'll even just take 1. E, anybody? Okay. First and last are no's. 3 is a no. 4 is going to go yes, no. 5 is yes. 6 is yes. 7 is no. Reminds me of Homer Simpson. Donuts. 8 is a drawing. Can anybody draw a 4-sided thing not convex? It's a lot easier to draw one that is. So you draw squares, rectangles, parallelograms, trapezoids, almost anything you could draw is convex. Anybody for 8 have one that's not a convex? Yeah, like an arrowheady kind of thing. Has 4 sides. 1, 2, 3, 4. That's not convex. That's the best you can do there probably on that one. 9, to draw coplanar half planes with a common edge on the first part of 9 is pretty easy. Just draw a plane and then use an edge to cut it in half. That would be coplanar half planes. If they're not in the same plane, then how's our drawing going to have to go? If things aren't in the same plane, what appears on drawing life? It did once already on the board today.
Have to go through it.
Yeah, it has to go through it, and how does that affect our drawing?
You have to draw it on.
Like we have to draw dotted stuff. Okay, so if we're trying to draw a thing that's like been folded in half, and some of it's in the plane and some of it's not, we're gonna have to make somehow something be dotted. So they wanna go something like regular half plane going one way, and then maybe that goes behind the board. You know, so there's a half plane that went behind the board, and there's a half plane that's on the board. We could go dotty stuff on that. That's not the only way you could draw that, but that would be a choice. 10, they want coplanar half planes, so I'm on my board, but they don't have a common edge. So I'll spot you one. There's a half plane. Now I want another half plane, but not with this same edge. So what am I going to do about that?
Draw another one.
Draw another one. So here's my other line. Which way you want me to go?
Doesn't matter.
Doesn't matter. So I could draw
Right or left.
to the right, or I could have drawn to the left. It doesn't really matter whether I draw it the same way or a different way. It makes really no difference. That's 10. 11, they want me to put together half planes, and we'll get into a discussion that Asa just sparked a second ago. If I put together two half planes, is it always going to make a whole plane?
No.
No. It depends on which way we go. So, because these both went right, do those make a whole plane?
No.
No, because nobody went left. Even if this went left, would that make a whole plane? If I put all of this together with all of that, does that make a full plane?
Yeah.
Still no. Why no? Putting this and that together doesn't make a full plane. Anybody a thought on why? There's this gap in the middle. Like this went to the right of here, this went to the left of there, nobody ever went into that zone. Putting two half planes together doesn't usually make a whole plane. So 11 feels like putting together two half planes should make a whole plane, but most of 11's answers are no's. 11A is a no, B is a no, C is a no, they're all no's. Because you don't know which way it's going, right or left, by any of their descriptions, and you don't know if there's like maybe a middle zone or something like that. It's just no, no, no. 12, you would try to draw a bunch of drawings. We're trying to do 3 lines. I'll clear some space. If I try to draw 3 lines, what's one way I could make a drawing of 3 lines?
A triangle.
It could be like a triangle thing. So we could go 1, 2, 3. How many areas, how many regions, how many, what did they say, how many separations into regions did we just make? How many zones are there here?
7.
7. 1, 2, 3, 4, 5, 6, 7. So is 7 possible? Yep. Somebody else, what's another way we could draw 3 lines other than triangulating them?
Parallel.
We could go all of them parallel. If we go all 3 lines parallel, how many regions are there?
3.
Count again.
5.
Count again. 1, 2, 3, 4. So is 4 possible? Yep. What's another way we could draw ourselves 3 lines?
Like 2 parallel and then 1 going through.
2 parallel, 1 go through. How many zones?
6.
6. 1, 2, 3, 4, 5, 6. So is 6 possible? Yep. What's another way you could draw 3 lines?
Like a snowflake?
Yeah. Like most of an asterisk, snowflake looking thing. How many did that make? 6. We already knew 6 was possible. There's no other really ways you could do that. 5 is a no, 3 is a no, so 12 goes no, yes, yes. 13's 4, then 3, and then I think that homework stops. You know better than I do whether you're saying right things or wrong things. You know better than I do whether you guessed yes, no on all the yes, no's, or whether you actually knew what you were doing. Let's talk about some if they're confusing to anybody not understand, need a little bit of tips on what happened on page 65. Anybody, anything, 65 confusions? Especially the ones that make the test. From this page, making the test was 1, 2, 3, 6, 7, 8, 11, 12. So if you don't understand 1, 2, 3, 6, 7, 8, 11, 12, let's take a minute on any of that. Page 69, we were doing some topology type games. So 1, A is a lose, B is a win, C is a lose, D is a lose, E is a win. Here's the ruling on this. Every area is either an even or odd area. This is an odd zone. Does anybody have a thought on why this is going to be called by me an odd zone?
There's 3.
There's 3 sides to it, so that's an odd zone. So this would be an odd zone. This bottom would be an odd zone. If you get too many odd zones, you can't do it. If you get for yourself 0 odds, you can draw the shape. If you get yourself 2 odds, you can draw the shape. But if you get anything other than 0 or 2 odds, you can't do the shape. That's the pattern to that one. B is a win, because what kind of zone is this?
Even.
Even, because it has 4 borders. This is even, this is even, this is even. If you have no odds, you'll win. If you have 2 odds, you'll win. If you have any other amount of odds, you're going to lose. That's what's going on in 1. Question about what 1 was about. That didn't make the test. 2, 3, 4 does make the test. 2, 3, 4 is going to be based on the vertexes. So this vertex right here would be an odd vertex. Anybody a thought on why this is an odd vertex?
Because there's 3 lines.
3 lines touch it. This vertex, odd. This vertex, odd. This vertex, odd. Same rule applies. If you have 0 odds, you'll be a winner. 2 odds will be a winner. Any other amount of odds, you're going to lose. So 2 is going to be a yes, a no, and a yes. Let me look at this one. Even or odd up top?
Even.
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 Even, because there's 4 touch it.
Odd.
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 Even.
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 Even. If you do try to redraw this, does anybody notice something about your drawing pertaining to the evens odds? Try to start here. Can you retrace it? Nope. Try to start here. Can you retrace it?
No.
No. But you can retrace it. What's up with the retrace?
You have to start the odd.
You have to start on an odd. If you start on an odd, you can retrace it. And where do you end up?
On the same on an even.
Let's try it and see. Start on an odd. Retrace.
On the other odd.
You'll end up on the other odd. Okay. 2 odds can be a win because that's your beginning and ending points. But if you have more than 2 odds, you can't do it because you can only have 1 beginning and 1 end. 3 is no, yes, yes. no, yes, yes. And 4, then they guide you into this whole even odd discussion. First picture of 4, how many odds does it have? Anybody 4A have an answer? How many odds there are in the first? I'll just leave that to you because that's just like boring counting. B, the winners will be based on the odds you have. How many odds make it a win?
0,
0 odds is a win?
2 odds.
2 odds is a win. So whichever ones have 0 and 2 odds, those are your wins. And that's 4. 5, we started the Mobius strip. We did that the other day. We cut it in half. We thought it would fall apart. It didn't. Our binds were blown, especially David's. Then we cut it again, and we were not sure what was going to happen, but we thought it was just going to get bigger, but it didn't. There were 2 of them. Then you cut it again, and I think you got 4 of them. Is that what happened? So, and they were like all like in a loop. So I have 2 funny things here in my box of mystery. Ugh. So once upon a time, there was a guy named Caleb Roach, and at the end of the year, there's a Caleb question. I told you you were all entitled to your own question. His question was something like, when is paper not dull? And the answer was, when its name is Mobius. Because what he was known for in his day, I don't know if you've ever seen old style computer paper, where it was paper you would tear apart, like it was threaded in a big pile, where this would be connected to this, where it would rip apart. Have you ever seen paper like that?
Yeah.
Yes, a few people have. But it would be like page after page after page after page after page after page. So he took about like 6 pages worth of this like paper that was perforated. He taped it at the end. So he had a Mobius strip originally that was like, yours was like this thick, his was like that wide. Yours was like 2 feet long, his was like 5 feet long. And he just started cutting it and cutting it and cutting it and cutting it and cutting it, and he gave it to me, and I put it in a box. Eventually, if you kept going, it would look something like this. Each one of these is its own little strip, and I'm not sure why he did that exactly, but it's sort of like humorous to me, so I saved it in my box. That's where we got in class, I think. I think where you got might have looked a little more like this, or maybe that's even one more cut than what you got. I'm not sure, but that's where your Mobius strip was going from where you started. But that's ridiculous item 1 in the box. Ridiculous item 2, if some of you remember Dylan Cribbs, he once gave me a birthday present of a thing called a Klein bottle. So if the Mobius strip blew your mind, wait till you see the Klein bottle. So the Klein bottle is something that has no inside or outside either. Like the Mobius strip, it didn't have a front and a back, it just had one side. So this is a 3-dimensional bottle that it doesn't have an inside or an outside, because the inside is the outside. So they suggest you not try to put water into what looks kind of like the inside, but is also the outside at the same time, because you'll never get the water like evaporate out of it, because it's just bizarre. See a Klein bottle, because you were the most fascinated by Mr. Mobius. There's accompanying paper that explains all about the Klein bottle if you want to read it, or you could Google Klein bottles. It says, searching for a one-sided surface, need a 0-volume bottle, want the ultimate in non-orientability, get an Acme Klein bottle, a topologist's delight, handcrafted in glass. Ever hear of a Mobius strip, a one-sided, one-edged surface? Well, here's the same thing, but in like solid form, essentially, and then it has all this like silliness in the description of that. 6. 6 is a yes. 7 is a no, and it's crazy. Why would 7 be completely ridiculous to think about a 5x5 square getting paved with dominoes?
Because it's odd.
Because it's an odd amount of stuff. There's no way 25 squares could get covered 2x2, so that's silly. If you take out a corner, the answer is a yes, because you went from 25 down to 24, and it actually works. 8, you probably mostly said yes, but it's a no. It just can't be done. If you try to take an 8 by 8 checkerboard, there'd be how many squares? 64. You could cover the 64 with dominoes, no problem. If you clip out the opposite corners, you're down to 62, but for whatever reason, you still can't do it. 8's a no. It's just not going to happen. 9, they want you to do triominoes. That's these like L-shaped guys. So 9A is a no, and it has no shot. If it's a 5 by 4 shape, there's 20 squares to cover. Why can't these triominoes do your 20 squares?
20's not visible.
20's not divisible by 3. 5 by 4, you take out the pair of corners, you're down to 18. Might you have a shot? Yeah, but you're not really sure unless you try to draw it. Okay? It will work. It is a yes. 6 by 6, 36 squares. Would it have a shot?
Yeah.
Yes, but unless you draw it, you're not probably really 100% sure, but it is a yes. 6 by 12, 8 by 9, the math works out on those. Those end up being yeses. But the only way you'd really be sure is if you actually try to draw it. But if you try to draw it, it would become a yes. But that was a good bit of topology questions. The ones on this that I would use on the test again, 2, 3, 4, 6, 7, 8, 9, that stuff, some reappearance of those kinds of things will come up. Anybody, page 69, any kind of questions about any of the homeworky stuff? So for tomorrow, game plan would be A, you fill in your sheet. If you do everything, that's worth 25 points out of 25. B, it wouldn't hurt to start to look at the homework questions, especially the ones that I say on this that are like good. If you have questions about those, I'd be happy to do that tomorrow. Another thing that I would highly endorse for the test is take this paper that I gave you. If you've never looked at it since I gave it to you, just read it at least like once. A lot of the homework questions you've done are the ideas from this sheet. A lot of the test questions are there for ideas from this sheet. Taking a read through this sheet and making sure you've got a grasp on what's on the sheet is a pretty good idea. When you go to fix the test, most of the answers you'll need someday to fix your test are on this sheet. So if you lost this sheet, I could get you another one, but reading this sheet before the test would be, I think, a pretty big help on the homework while you put questions. Is your mind officially blown by that?
I want to put water in it.
Yeah, I know, because as soon as I said, I have to put water in it. That's what everyone wants to do,
I want
yeah.
to see what will happen.
Yeah.
It would fill up from the
There's a
bottom. That's
famous poem my dad used to like to say, why did the children put beans in their ears when the only thing we told the children not to do was to put beans in their ears? Why did the children put molasses on the cat when the only thing we told the children not to do is put molasses on the cat? There's something in the human nature, as soon as you tell somebody something they shouldn't do, there's like a little piece of them that just like wants to do that.
We use like
Get it out
a,
of me.
Like,
we like,
don't think about elephants. Well, see, now you just want to think about elephants all day.
what if we like take like a little piece of paper and crumble it up into a ball?
You could get water
It
back
would go in, and it would end up like in this blob somewhere somehow.
But then by turning it upside down, you can get it to come back out, and if you did it right, you could get it to come back out the entrance that's actually the exit.
You could, yeah.
There's also many
I
times
want
filled
one
out
of
with
those.
water and TikTok and they couldn't even get
Dave's gonna
water.
get one just to put water in it to see what
Like they,
happens.
well, it's like
So exactly.
Fine bottles have made it on TikTok. Wow, they've hit it big. Trending on social media. Okay.
They tried
Madness.
to like put it in